Hello guys. So in today's video we are going to discuss the solution of the problem maximum value of expression. So basically we are given an array. So in this problem statement we are given an array this, and we need to find the maximum value of the expression a of I minus a of j plus I minus j, and these two terms are in modulus. So this is what we need to do here. Okay, so let us discuss the problem statement and the solution further. Okay, let me go back to my journal. Okay, yeah, this is what I wanted. Yeah, so let us discuss the problem statement first. So the problem statement basically says is that given an array A of size, okay, just a second guys, A of size n, we need to find out the maximum value of expression. What is the expression? A of I minus a of j plus I minus j. So this is the expression and we want to find out the maximum values, right? And obviously I and j is basically n and 0, between 0 to n, right? So the brute force solution is very obvious. Basically we will iterate on, so we'll take all the possible ai and aj and we will perform we will evaluate this expression a of I minus a of j plus I minus j, and we will find the maximum value there and then we will return it. So that's the brute force approach, and the running time complexity, as you already know, is n squared, since that involves two loop. Okay, so but here in this video I'll be focusing more on the optimal solution. So let us discuss the optimal solution for this problem. Okay, so in order to understand the optimal solution, let us divide this expression. So basically this expression, we will study more about this expression and then we will try to formulate our optimal solution. Okay, so as you know that I minus j, so just a quick background on the modulus operation. So modulus of a evaluates to a if a is greater than or equals to 0 and minus a if a is less than 0, right? So like minus 3 is 3 and 3 is basically 3. Okay, so I'm sure you might be already aware of it, but just for completeness sake I have just given a overview of the modulus operation. Okay, anyway, so let us do this. Let us take this and divide it on the basis of, or expand it on the basis of this approach. Okay, so what we can say is basically, let us say this expression is a and this expression is b. So what I'm saying is that a is equals to modulo of ai minus aj, okay, and b is equals to modulo of I minus j. Okay, now given these two terms a and b, we can formulate 4 cases basically. So case 1 is when a is greater than or equals to 0 and b is also greater than or equals to 0, right? Case 2 would be a is greater than or equals to 0 but b is less than 0, and case 3 is basically a is less than 0 and b is greater than 0, and the final case is case 4, right? So these are the 4 possible cases, right? A is less than 0 and b is also less than 0, right? These are the only 4 cases which are possible in this problem or for this expression. Okay, So let us expand this now. Okay, so now a is greater than 0. So we know by this definition, if a is greater than 0, then a translates to a. So this becomes basically, so here the translation, let me use a different color. So our expression, so let us just write down our expression. So our expression was this, and in terms of if in terms of a and b, the expression will be basically a plus b, right? If a is this and b is this, then the expression will evaluate to a plus b simply. Okay, now if a is greater than or equals to 0, then a is a, and what is the value of b? B is also greater than 0, so b is b. Okay, here if a is greater than or equals to 0, so a becomes a and b becomes minus b, right? I hope this makes sense, right? And a is less than 0, so minus a, and b is greater than 0 is b. Here basically minus a minus b, and this we can write it down as a plus b. Okay, and let us rearrange this. This can be written as a minus b. Negative I am taking as common, and this is actually a minus b, so this is fine. Okay, now let us plug the values of a and b and get our resultant equation. Okay, so a is basically what? A is a of I. So I'm putting the values of a and b in this equation. A is a of I and a of j, and this is, and b is what? I minus j, right? Now let us rearrange it. This can be written as a of I plus I, and this can be written as a of j. Sorry, let me just take these square brackets. A of j, and I'm taking negative as common, and minus plus minus. So if we put a minus here, this will do our job, right? Okay, and here, since a minus minus we can take common, and all right, let us write as a minus b. And what is a minus? A minus b is this basically. So let me just write it down. A of I. So I'm using this equation, and we already know the values of a minus b, right? A minus b is this. So I'm just replacing it. A of I minus a of j minus j. Okay. All right. Similarly here. Oh, okay. We missed to solve case 1. I'm sorry about that. So a plus b is basically what? Let me just write it down. A of I minus a of j plus I minus j. So this is basically, let us rearrange it. A of I plus I, and we can take minus as common, and this is aj plus j, isn't it? Yeah, aj plus j. Yep. And let us similarly evaluate this again, minus of a plus b. So a plus b we just have taken it out, so let us just use that. What is the value of a? This is the value of a plus b, so let us plug that. A of I plus I minus a of j plus j. Yeah. Okay. Okay, so these are the 4 equations which we will get. So this is our equation 1. This will be our equation 2. This is the equation 3, and this is our equation 4. These are the 4 equations we will get, and the objective is basically to find the maximum value of these 4 equations. So we'll iterate on all the arrays. We will evaluate these 4 conditions. We will evaluate these 4 expression and we will find the maximum value. And similarly, when we have gone through all the elements, the maximum value which will be stored in the variable maximum value is our answer, and we will return that. Okay. Now let us look at further. Do we really have to explore, or do we really have to expand all these four equations, or do we really have to operate on all these four equations? Well, the answer to that question is no. We really don't have to go ahead and expand all these equations. Okay, operate on all these equations. For that matter, actually, we just need to operate on two equations, and the other two equations are equivalent to the first two equations. So let us explore that. What do I mean by equivalence here? So let us take case 1, which is a plus b, and case 4, which is negative of a plus b. So as you can see, with an exception of this negative sign, right? With the exception of this negative sign, case 1 and case 4 are same, right? Now let us try to understand. So basically it will evaluate to the same value. One will be the positive value and the second will be the negative value. Okay, I mean, from the equation it looks like that way. But does it really the case? Is equation 1 and equation 4 are equivalent, right? So let us explore this, whether equation 1 and equation 4 are equivalent or not. Okay, so let us take this equation 1. So if I want to maximize the value of equation 1, then what do I need to do is that I have to maximize the value of ai plus I, and I have to minimize the value of aj minus j, right? If I do so, the difference between these two will be the maximum one, isn't it? Right? So case 1 will be expanded in that form. I mean, you can intuitively think of in that way. And let us look at case 4. So let me just expand case 4 a little bit more. So this basically becomes ai plus I, right? And minus minus plus aj plus j, right? And if we want to maximize the value of this equation, what we need to do is basically I need to maximize this value, isn't it? Right? And minimize this value, right? That is how the resultant of these two will be the maximum, right? So if you see in case 1, we are in case 1 we were maximizing ai plus I, right? In case 1, in equation 1 we were maximizing ai plus I, whereas in equation 4 we are maximizing aj plus j. Okay, similarly here we were minimizing aj plus j, and here we are minimizing ai plus I, right? So I and j are alternating, but eventually we are maximizing one term and we are minimizing the other term. Okay, now let us forget about I and j for the matter, and let us see which term we are maximizing and which term we are minimizing. Okay, so basically if you see in a case 1, okay, so let me just use a different, or okay, let me just take this and scroll up one. Okay, let's go to next one. So this is case 1. Okay, sorry about this. This is case 1 and this is case 4. So let us see which value we were maximizing in case 1, and for let us look at case 4 and then we'll go to case 1, and let us, for now, for time being, let us forget about I and j. So the term which I am trying to maximize here is, in case 4, is this, right? This term is what I was trying to maximize. So in a way I was trying to maximize a plus I. Okay, okay, it's better to call it x, right? A of, okay, let me just rewrite it, ax plus x. This term I was trying to maximize this, right? And which term I was trying to minimize? Well, the term which I was trying to minimize is this ai plus I, right? So again, the same term is what I am trying to minimize also. Okay, so this term I was trying to minimize. Nice. Okay, now let us look at case 1. Again, which term I was trying to maximize? ai plus I, which is ax plus x, and which term I was trying to minimize? Again, aj plus j, which is ax plus x, right? So essentially, I was just trying to show you that a term which we are trying to maximize here, okay, or let me write it down like this. So here, this we were trying to maximize, okay, and let me use this we were trying to minimize. Okay, so basically what I was trying to show you is that in case 1 and case 4, the term which we were trying to maximize is ax plus x. So here also we were trying to maximize the same term, ax plus x. Sorry, like, let me take this, ax plus x, and the term which we are trying to minimize is the same, right? And this x and x don't go on that exactly, because then it will become all the same thing, and maybe it will translate to 2x or something. But don't go on x. Try to understand it from intuitive perspective. So basically, in case 1 and case 4, the term which we were trying to maximize is the same, and the term we were trying to minimize is the same. And that is why the resultant maximum value minus minimum value will be same for case 1 and case 4. Okay. Okay, so let us, okay, I'm sure this would be a bit confusing, so let us explore it a bit further with the help of an example. So, right, so our example was, and by the way, just on the similar note, case 3 and case 4 are equivalent. Okay, this thing, case 3 and case 4 are also equivalent. So in a way, I just have to operate on case 1, and I'm so sorry, not case 3 and case 4. Case 2 and case 3 are equivalent. Okay, because the term which you will try to maximize and minimize in case 2 and case 3 are same, right? Okay, so case 1 and case 4 are equivalent, so that can be considered as one case. Case 2 and case 3 are equivalent, so that could be considered as one case. Okay, so in a way, we just have to operate on two cases. Okay, so the first case is ai plus I, and so the first case is ai plus I and aj plus j. We have to maximize and minimize these cases. And in the second one, which is ai plus I and aj minus j. Okay, so these are the terms we have to operate on. And okay, now let us understand it a bit further with the help of an example. So in this example, we were having, let us take this example. For instance, let's say the values in the array is, okay, let's do this. Let's take the example which was there here. So the example here is basically 1, 2, 3, 1, and the output is 4. So let us take that example. Okay, yeah. So the example was basically 1, 2, 3, 1. Okay. Now, okay, so let us seek out. Okay, so these are the indexes: 0th index, okay, first index, second index, third index, right? There are 4 indexes only. And let's say this denotes, basically here I want to find out ai plus I. Okay, here I want to find out ai minus I, right? Because these are the two terms which are being used across. In all the cases, if you see, the terms which are being used as ai plus I. You just need to evaluate ai plus I or aj plus j, which is basically the same thing. And the other term which you need to evaluate is aj minus j, right? aj minus j. So that is what we will evaluate, and then we will look at the 4 cases. So this will be our case 1 and case 4, case 3 and case 2. So let us evaluate the terms here. So let us evaluate this column first, ai plus I. So this is 1 plus 0 is 1, 2 plus 1 is 3, 3 plus 2 is 5, and 1 plus 3 is 4. Okay. And ai minus I, let us evaluate. 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1, and 1 minus 3 is what? Minus 2. Okay. So these are the terms. Now let us try to find out the maximum value which I can obtain using the case 1. Okay. So the case 1 says find the maximum value of ai plus I and find the minimum value of aj plus j, and then subtract these two values, right? So basically we want to operate on I plus I in case 1. So the maximum value is, so maximum value, let me denote it by this color. So the maximum value is 5, right here, 5, and let me denote minimum by red, and minimum is what? 1, right? The minimum value is 1. So using case 1, the resultant value we will obtain is basically 4, right? 5 minus 1 is 4. Okay. Now let us look at case 4. Case 4 says I want to find the maximum value of aj plus j and I want to find the minimum value of ai plus I. So the maximum value of ai plus I is again 5, and the minimum value is 1, right? And case 4 in the same way will result into 4, right? So that is what I was trying to refer, is case 1 and case 4 are equivalent. I hope by now it will be very clear that case 1 and case 4 are same. Okay. Now let us look at case 3. Case 3 says I want to find the maximum value of case 3. I want to find the maximum value of, or let's take case 2 also. It's the same thing, ai plus I and j minus j. Okay. Okay. All right. I'm just wondering if I have translated the equation properly. Oh, that is the problem. The equation was not translated properly. So this is basically minus. I'm so sorry, guys. Right? So if you ai and this is minus, so this is minus, right? This is not plus, this is minus. And case 3 also, if you look at carefully, minus of a plus b minus of a minus 1, so ai, and then what is minus here? So again this is also minus, right? Okay, I'm sorry about this, guys, but this is just minus and minus over here. Okay, so again, so in case 2 and case 3, what do I want to find out? The maximum and minimum value in ai minus I, basically. So let us find the maximum and minimum values here. So the maximum value is 1. Let me use the same color. Maximum value is 1 and minimum value is minus 2. And if you subtract these two, 1 minus 2 is 3, right? 1 minus 2 is 3. So here and here also you'll get the 3. So the answer to this problem is 4. Okay. I hope the explanation is clear to you. And in case if still there are confusion, please feel free to drop a comment and I'll try to address them. Okay. So having understood this, let us try to write down a code for this. Okay, so let me go to my editor. Yeah. Okay. So the way we said is basically I want to find out the maximum and minimum. So let me take a variable max1, and max1 is basically max size. So I'm initializing maximum one with negative infinity. Okay, minimum one equals to sys dot max size, and minimum with positive infinity. And similarly, I need second also. Okay, two variables are there, and all we need to do is that for I in index, I in range n, and we have to find out the value 1, which is what? So the first value was what? Let me just quickly show you. So the first value which we wanted to find out is basically I plus I, and the second times we wanted to find out I minus I. Okay, so let me find out the I minus I. So A of I plus I, and the second value we wanted to find out is A of I minus I. Okay, and let us just, for safety perspective, I'm just converting it to integer. Sometimes they operate on something else. So anyways, this should do. And let us find out the max1. So max1 is basically max of max1 and val1. All right. Similarly, min1 is basically min of, right? So basically I'll visit that again. What exactly I'm doing here is basically, you see this. Okay, val1 here. So let's look at this. Okay, so for in our solution we were, so in case 1 or case 4, which is the same thing, now we understand that. So in case 1 we were finding the maximum value of ai plus I and minimum value of ai plus I, and we were finding the difference between these two. So that is what I am trying to do here. I am trying to find out the maximum value and minimum value in the operation ai plus I. Similarly, I'll try to find out the maximum, okay, in operation 2. So this is my operation 2, and I am trying to find the maximum and minimum there. So once this loop ends, I'll have the maximum and the minimum. Those 4 values, max 1, min 1, max 2, min 2, I do have. And all I need to do is basically return max. Okay, let me use this return. Okay, max of max 1 comma, max 1 minus minimum 1, right? That is how you'll get the maximum value, and max 2 minus min 2. Let me put the brackets appropriately, otherwise it might create. Okay, I think, okay, and that's all. That is the that is how we do it. And let me just try to run it. Okay, so this passes here, the output is good. Let me submit my solution. And the solution passes. Okay, that's all guys for this video. I hope it makes sense to you. In case if you have any confusion, please feel free to drop a comment and I'll try to address it. Thank you.